live. Welcome, everyone. So, good morning and good afternoon to all of you. Hello, Universal Consensus System. And I'm really excited to be here today with all of you to discuss this wonderful topic, why Inc., Polkadot's smart contract language. So let's get started. The agenda, high-level agenda for today, I'm going to be talking about what is Inc. for those of you who are uninitiated, who don't know what Inc. is, who are uninstantiated. And then we're going to talk about why Inc. Like, why is Inc. such a great smart contract programming language? And as I'm discussing about what Inc. is, there's also going to be some fragments there of why it's such a great smart contract programming language. And as I'm going over this, I want you all to have in the background, like thinking of any questions that you may have, or for those of you who are seasoned Inc. developers, I would love to hear your reason why you personally think Inc. is just great, right? So I'd love to have that feedback at the end. So just think about that as we go through this. So let's get started. What is Inc? For those of you who are new, right? Inc is Rust. I'm just going to keep it like that's simple. Inc is Rust. So if you want to write smart contracts on Polkadot with Rust, use Inc. Rust is a programming language, right? So Rust right now, there was a survey done. The link is there. Rust has 4 million. There's 4 million Rust developers. 4 million in the world, right? Compared to 26,000 Web3 developers. That includes Solidity. All right, so that's a lot of Rust developers. So I want to come with this presentation from different angles, right? So like if we think of it from the business perspective, right? From the business perspective, it's good to have different avenues into Polkadot. So you have 4 million Rust developers. We create an avenue for Rust developers. Diversity in general creates strength. So catering to different paths, one of them being Rust, is an excellent strategy. Now, granted, out of those 26,000 Web3 developers, they're already onboarded, right? And we all know how freaking hard it is to onboard Web2 developers into Web3, right? So that is clear. However, Inc. makes it really, really easy to write smart contracts in Rust. So onboarding Web2 developers, like it's just like, I'll show you in a little bit. It's the way that Inc. was created. It's just, there's simplicity in it, right? So from another perspective as well, like investing in Rust, I like to say when other people come to me like, hey, I want to get into Web3, right? I'm a Web2 developer. How do I get into Web3? Well, my suggestion is always like learn Rust, because with Rust, you can't fail. Say they get into Web3 and they're like, oh, this isn't for me, or maybe they can't get a job for some reason, right? They always have that fallback strategy where they invested in Rust. So they invested in their software development career. So Rust has many jobs outside of even Web3, right? So you can't go wrong with Rust. But of course, they'll stay in Web3. So why is Rust an ideal smart contract language? Well, Rust in itself incorporates years of language research. It's safe and fast. It is type safe. Rust has strong types. It is memory safe. Rust doesn't use a garbage collector. It uses ownership model for memory ownership. And it's free of undefined behaviors. So as all of you who've been programming in Rust, we like to call the Rust compiler, the strict schoolmaster. So it's really, really hard to get past that compiler with some of the top errors, you could say, in other systems programming languages. So Rust is also small, which is perfect for a space-constrained blockchain world, right? So some examples of what Rust does. So the compiler reorders the struct fields to make each type as small as possible. Okay, so it does that a little bit of that. That's one example of an optimization. Rust data structures are very compact, in many cases even more compact than C. So in Rust, you can use higher level data structures for the price of low level code. The compiler optimizes and does that for you. So you're writing high level data structures, but once it's compiled, you get it at the price of low level code. That's pretty cool. When you're working with Inc, you're working with Rust. Inc follows Rust standards, such as Rust Analyzer, gives you feedback on your code. You can use Rust IDEs. So like, for example, my team, half my team right now is using Rust Rover, which is a really cool Rust IDE. They're using that for smart contract and blockchain development. So you can use tools like Rust Format. You can use Clippy. Clippy is a linting tool for Rust. You also have access to Cargo and crates.io. So Cargo, for those of you who are familiar with like NPM, right? NPM is a package manager. Cargo is a package manager for Rust. So you have all these crates that are available that the open source community created in the crates.io. That's all available. You can just do Cargo install, right? We're not reinventing the wheel. And there's a lot of cool VS Code extensions for those of you who use VS Code. So the tooling is available to you. One of the things that we discussed about a lot this year in Polkadot is DevX, right? So this is a programming language that has excellent DevX. It was voted the most loved programming language for 7 years in a row. So it's a great choice for Polkadot. And the community, when you invest in Inc, when you invest in Rust, you're all automatically part of the community, right? So we said 4 million developers. So because Inc follows Rust standards, as Rust evolves, Inc will be right there next to it, right? So community is accessible. Rust is also safe and efficient. So what do we mean by that? Like, for example, I'd like to give 2 examples here with the no overhead and minimal runtime. So one of my favorite examples is monomorphization, right? Like, what is that? That's a big word, right? Really, it just shows how, like, for example, in Rust, when you write generics, right? So you have some generics, or you have one generic, let's say, but in your code, you're only using it for a specific type, right? So the compiler will check that when it compiles. It'll say, well, I can see that you're only using that generic for one specific type, so I'm not going to include the code for all the types. I'm going to just take that concrete type that you're using in your code, and I'm going to use that. And so it optimizes for that. So you get a smaller output there. Or like when you're working with smart contracts with Inc, for example, there's a debug. So you can build your contract in debug mode, which you get some debug functionality. You can also build your contract in release mode, which does some optimizations. The Rust compiler does some optimizations to make your output smaller, right? So a lot of the times when I've been compiling contracts in debug and release, I've noticed that the difference is less than half the size for release. So it's a lot smaller. Rust also has first-class support for WASM, WebAssembly. So with Inc, we use WASM. So we actually use both targets. So Rust can compile to 2 targets. One is just the native binary, and the other one is the WebAssembly. So in Inc, we use both. The native binary we use for end-to-end tests, for running tests. WebAssembly we use for production, for when we're ready to deploy our smart contract. So why WebAssembly? WebAssembly is highly performant. It's fast because it's built close to native machine code. It's platform independent. So it was built for, like, for example, like space constrained, like mediums, like for example, browsers, right? Or like in here it says it can be shipped over the internet to devices with potentially slow internet connections. So it was built with that in mind, which is great for the blockchain, right? So if we're thinking of Inc smart contracts, when we compile it down to WebAssembly, we have to upload that code to a blockchain, right? An Inc compatible blockchain. So all these little WASMs, they get uploaded to a substrate-based blockchain. So WebAssembly is a great choice for that. and WebAssembly is performant. It's fast. Also, one note on this too, PVM support is coming. It's going to be even faster, right? So we're looking forward to that for Ink. So WebAssembly and Rust are backed and used by large companies. That is a great indicator, right? And it's continuously being developed and improved. But perhaps my personal favorite indicator is that Rust is used in the Polkadot SDK, right? It's not used. The Polkadot SDK was built with Rust, right? So when you're learning Rust, like I tell this to like new developers that are coming into the Polkadot ecosystem, and I say, well, you start with Ink, you start with smart contracts. You learn Rust if you're new to Rust. You start developing logic with Ink smart contracts. You get really good at it. And when you want to go deeper, then you can go towards building a blockchain, right? And because you've already invested, 1 or 2 years of like writing Rust, you'll be warmed up to write like a parachain or a blockchain, right? Using the Polkadot SDK. So it's a great on-ramp. Rust is a great on-ramp for the entire Polkadot tech stack. I also want to make another comment here, is that from my personal experience, when I'm writing smart contract with Ink, sometimes for debugging purposes, I do need to go into palette contracts, right? Palette contracts is the module, the palette that runs the Ink smart contracts, right? It's part of the Polkadot SDK. And sometimes I need to go down to that level to debug certain things with Ink smart contracts, such as errors, right? Sometimes I get some cryptic errors. So then I go into the Polkadot SDK substrate / frame / palette contracts, and I look at the errors and like, what do they mean? Where do they originate? So for you to do that, you need to know Rust. So even if you are programming in a smart contract other than Ink, you're still going to have to learn a bit of Rust once you start getting to a certain level of advancement. Ink is a next level smart contract language. So Ink took some major learnings from some older smart contract languages and incorporated them into Ink. One example that I like to give are interfaces. I like to give this example because the way that Ink chose to allow developers to create interfaces was really cool. So the way that you do it with Ink is by using Rust traits. So it's like Ink didn't have to reinvent anything. You can just define, create traits and use that as the interface to define behavior on your smart contract. And it could be shared behavior, meaning that you can define an interface that multiple smart contracts can use. So you define it in one place. It can be even outside of the smart contract, and you import it as a crate and you implement that interface. So this is one really cool example, in my opinion, of like, it's kind of like the Rust way of doing things. But Ink is there. Ink facilitates. Ink allows that to happen, right? So at the end of the day, I like to show a picture. What is Ink? Ink is Rust. Plus, it's got some macro magic. And it's got some types and some APIs. And all of that will compile down to WebAssembly, which is what you upload to the blockchain, right? So when I say macro magic, well, when I say types, for example, with the Ink library, you get access to certain blockchain types, such as account ID, right? So this is a blockchain type. This is like what Substrate defines as. Substrate is a blockchain framework. It's what it defines as an account ID. And those of you who are familiar with Substrate was written in a very generic way. So on the blockchain level, when you're writing blockchain logic, you can define an account ID as you want, right? And that's available through the Ink library. You have access to the account ID type. You have access to other blockchain types, such as like balance, such as hash. And you also have this macro magic and these APIs that Ink gives you. And a lot of times it's kind of invisible. So for example, in Ink, when you create the storage for your smart contract or the state for your smart contract, You can mutate that state. You can read that state. Ink makes it effortless. You don't even know how Ink is doing that. You don't need to know, but you can do that, right? Via its APIs. So I want to show another picture. So I like this picture because it's actual code, right? We talk a lot, but like this is the code, right? Here's an example code. It's an ERC20 token in Ink, right? Those of you who are not developers, I still think that you can appreciate the simplicity here. So that very first line with a pound, it's an attribute macro, that's Ink. And it's saying, hey, we're about to define a smart contract. And then you can see that there's another pound sign there with a storage. And it's saying, hey, we're about to define the storage for this smart contract. And it's all Rust. So you can see also, though, that total supply is of type balance, right? So that balance, it's a blockchain type. There's account ID in the next one. That's a blockchain type, right? That's all available because of Ink and the simplicity of it, how we're defining that storage just by creating a Rust struct, right? That's Ink, because Ink under the hood, it knows that that's storage. So it's going to create those getters, those mutators, everything for you that you can use later to modify the state of your smart contract, right? So let's look at one more image. So that top one there is the constructor. So Ink, when you're working with Ink smart contracts, Ink allows you to create a constructor, right? A constructor is what you use to instantiate your smart contract. So the initial state, a lot of times it's the initial state of your smart contract, right? So it's defined in a constructor and it's just Rust. On the bottom left, we're using the Ink message, right? And that's a function. So how can you interact with your smart contract? What's the API of your smart contract? With Ink, you can do that. That's a simple example there. Total supply, it returns the total supply. Now self.total supply, what is that? Well, if we look at the storage, total supply is part of storage, right? And it just says self.total supply, it'll return that, right? How does Ink do that? You don't need to know. Ink does that for you, right? So it's simple, it's easy to use, right? In fact, is there much blockchain, like there isn't, so if we look here, there isn't much like blockchain jargon here, right? Web 2 developer could really understand this. Like this is actually simpler than a lot of Web 2 stuff actually, right? So the simplicity is there. And then on the right-hand side, the bottom right, you see the events, right? So with Ink, you can create events, right? So you don't need to reinvent the wheel. You don't need, as a developer, you don't need to create the idea of an event, right? You don't need to use Rust and say, this is what an event is. This is how an event works. No, Ink does that for you. All you need to do is define the event that you want. In this case, it's a transfer event, and it'll say, okay, transfer from this account to that account, and how much was transferred, right? Real easy, simple, okay? So Ink, that macro magic, it takes care of a lot of that smart contract logic, right? Otherwise, you'd have to write all that code yourself. So hopefully that was enough for like why Ink, right? Like maybe I could end my presentation right there, right? So think about that for a second. Have a sip of coffee. This is Rust. Okay, so I'm not going to end it there because I think that the next portion is, for me, it's the most exciting portion of like why Ink. So let's continue. So Ink gives you access to Polkadot. Think about that. So in the simplest case, with Ink, you can deploy to Polkadot. Ink is the lowest barrier to entry to Polkadot, right? You can write a small Ink smart contract in half a day, and you can deploy it to a Polkadot compatible Ink blockchain in half a day. That's pretty cool, right? And that's what we need right now in Polkadot, low barrier to entry. Ink is the easiest path for tapping into Polkadot. So when I think of Ink, I think of like all these small pieces of logic, right? Each one is a smart contract, kind of like puzzle pieces that these smart contracts can connect with each other. So with Ink, you can write these small pieces of logic and deploy them to Polkadot. You don't need to build a blockchain. Ink is native to Polkadot. What do we mean by that? Well, Ink was written by Parity for Polkadot, right? So if those of you who don't know much of the history, Dr. Gavin Wood, creator of Polkadot, prior his work, he was working at Ethereum. He created Solidity. He was the, I believe, CTO there, right? Co-founder of Ethereum, and he created Solidity. Then he had some other ideas, and he branched out, created Polkadot to implement those ideas. And the company that he founded was Parity. Parity created Polkadot. Parity also created Ink, right? So Ink is native to Polkadot. What do I mean by that? Well, I hinted before, I said pallet contracts, right? Pallet contracts is inside of the Polkadot SDK. Specifically, it's inside of the Substrate blockchain framework inside the Polkadot SDK. And pallet contracts is the code that runs Ink. Ink runs on pallet contracts, right? So when Ink was being built, when pallet contracts was being built, pallet contracts was being built with the idea to run Ink, right? So it's native. One other example that I like to give, this was, I can't take credit for this idea. This idea came from my coworker. He's like, okay, take a look at these 2 blocks of code, right? This is an XCM message, right? Tell me which one is the message on the blockchain, like if you were to write a pallet, on a blockchain level, on Substrate, and which one is the one that goes into an Ink smart contract. You can't tell the difference, right? Because there is no difference. So the code that you'd be running on a blockchain, on a Substrate-based blockchain, on a parachain, right? In terms of this XCM, is the same code that you'd run in an Ink smart contract. All right, so when you're with Ink, you're in line with Polkadot. Okay. So why Ink? It's like, Bruno, give me another reason. Give me something else. This is actually a screenshot from the other day from a meeting that my team had, and this is what gets me going, right? Like working at Rogue and Pop Network. This image for me is like, this shows the potential. Right, so we see there on the bottom there, Pop Network, there's a smart contract. And the smart contract is living on Pop Network, right, parachain. And it can have controls over, it can do logic on the relay chain via its computed origin. And it can also do logic on Asset Hub or another parachain, right? So this is, to me, this is the beauty of what you can do with Ink, right? You can write a smart contract that can interact with Asset Hub, which will soon be Plaza, right? And so you can have this composability of like, okay, I want to do something on Pop Network, and then I'm going to send a cross-chain message to Asset Hub, and I'm going to transfer, 10 dot from Alice to Bob on Asset Hub, and then from there, I'm going to send another XCM back to Pop Network and do some logic there, right? This is what we're working towards. And Ink will facilitate this. You don't need to build a blockchain. You don't need to build logic in a blockchain to do this. So one more. I'm going to leave you with this. So from experience, building a parachain is hard. Not that you shouldn't do it. If we look at this graph, right? If you look at this chart, on the left-hand side, you see development time. And on the bottom, you see difficulty, right? So building a parachain with a custom node is the most difficult. Like think in terms of like if you want to have your own custom consensus system, right? That's custom node type of stuff. That's more difficult. Building a parachain without frame. So frame is like all this logic that you can use to build your blockchain's runtime. It's kind of like these cargo crates, like how you use cargo crates, right? Like it's like these, I like to think of them as Legos, right? You don't need, for example, like there's a frame pallet, there's a frame piece of logic, right? That says like, oh, this is logic for staking, This is logic for balances. If you want to have balances, this is logic for NFTs. This is logic for fungibles slash assets, right? That's already pre-built for you. So when you're creating your runtime for your parachain, you can use Frame to kind of plug all these together, and you don't have to reinvent the wheel, right? So that's building a parachain with Frame, which you see on the towards the lower end right there. Now, without all that stuff, you'd have to write all that code. Not easy, right? Even with Frame, it's not easy. I mean, to create an actual production ready blockchain, it takes a lot of skill and time. Whereas on the bottom there, you see Ink smart contracts on a Ink compatible blockchain or parachain. That's easy. I'm not going to say easy, but it's simpler, right? Because easy is a relative term for some, who don't know even Rust. It might be difficult, right? But it's simpler. It's a lot simpler, actually. That's why there's a gap there. So my tip, usually, if people are like, when should I use a smart contract in Polkadot? When should I build a blockchain, right? I just say, like, start with Ink. Start with a smart contract, then go from there, right? Now, if you know right off the bat that you want to create like this custom consensus system, then yeah, heck yeah, like you're going to have to build a blockchain. And running a parachain is costly. Like we know that from personal experience at Rogue. You're going to have to purchase core time. You're going to have to run collators. You need a super skilled team, so you may need to hire these developers, right? And they need to be 24/7 available to triage issues if any issues come up. And if you're building an ecosystem with this blockchain, you're going to have to incentivize the community in some sort of way. Whereas with Ink, it's lightweight, it's not costly, right? You can test an idea out very quickly. So hopefully that was that helped give the reason onto like why Ink